Hi learners, welcome. In this video I am going to explain a divalent rhenium complex where there are many interesting factors about this complex, and I am going to discuss one by one. Let's see first hybridization. So what type of hybridization here the rhenium metal is to undergo, and there are two rhenium metals here, and let's see what is the atomic number of rhenium. It's 75, and valence state electronic configuration of rhenium is 4f14, 5d5, 6s2, 7p0, sorry 6p0. Okay, so this is the electronic configuration of rhenium. But in this complex, if you see, we have to know the oxidation state of rhenium first. So two rhenium metals we have, we need to find its oxidation state. So let's say x, 2x, and we know chlorine is having minus charge, so minus 8 is equal to 2 minus 2x is equal to 6, and that means x is equal to 3. So here rhenium is existing in +3 oxidation state. So let's see rhenium +3 oxidation state. What is the valence electronic configuration of this? Now, I'm only taking the orbitals, I'm leaving these two, and 5d, 1 electron from here, 2 electron from this s orbital should be removed to get a rhenium +3. So 5d4, 6s0 and 6p0. So this is the valence state electronic configuration of rhenium 3 metal. Now there are two rhenium 3 metals. Let's first write in orbital diagram. One, two, three, four, five. So how many electrons we have? 1, 2, 3, 4. And this is one rhenium 3 metal, but there are two rhenium 3 metals here. So it is a metal cluster. 1, 2, 3, 4, 5. What are the remaining orbitals? Let's give the name. This is d orbital, s, p. Similar, this is d, this is s, and this is p. And here you can see there are four. We need four orbitals on each rhenium to bond with 4 chlorines. So here it will undergo d, 1 d orbital, 1 s orbital, and 2 p orbital. And here also it will undergo dsp2 hybridization. So the central atom rhenium 2 will undergo dsp2 hybridization. So whenever you say dsp2 hybridization, the shape of the molecule is square planar. Square planar. And how the structure will be? Let's see the structure. Okay, each rhenium is accepting 4 lone pairs from 4 chlorine atoms, chloride ligands, sorry, and they form a square planar in this way. This is one, and one more. That what we discussed till now. Structure of rhenium chloride. There are 2 units of ReCl4. These are the 2 units of rhenium. Next, what we have to discuss, till now I just discussed about the metal and how it is being bonded with ligands. Now let's see how metal-metal bonds will be formed in this case. If you see here, and dx square y square orbital is undergoing overlap hybridization in this case. And what are the rest of the orbitals that we have? dxy, dyz, dzx, dz square. Similarly here also we have dxy, dyz, dzx and dz square orbitals. Now let's see how they undergo hybridization to form metal-metal bonds. Here dz square of one rhenium metal will undergo overlap with dz square of other rhenium metal and gives a sigma bond. On the axis overlap is so here it will be having this shape, z axis. So they undergo on the axis overlap on the axis overlap and gives dz square, dz square. This is dz square hybrid orbital. It is undergoing on the axis overlap. This is z axis. Okay, so this is resulting sigma bond. Next, what else we have? You can see here dyz dzx, dyz dzx. They undergo sideways overlap. They used to have lobes in between the axis. They undergo sideways overlap in this way and forms a pi bond. Similarly, it's the dxz. Similarly, dyz will undergo sideways overlap and forms another pi bond. So these two orbitals are giving pi bonds because they are undergoing sideways overlap, and this is giving sigma bond. Already we have. What else we are left with? We are left with dxy, and here dxy orbital will also undergo sideways overlap. It will also undergo sideways overlap in this way. dxy of one rhenium metal and dxy orbital of another rhenium undergo sideways overlap and gives delta bond, and gives a delta bond. Third type of bond, you know sigma and pi. This is the third type of bond which is called delta bond, and this is the fourth bond that exists between two. Then you can see the four half-filled orbitals, d orbitals of rhenium will undergo overlap with four half-filled orbitals of other rhenium metal. One is on the axis overlap, two are sideways overlap, and the third one is also a sideways overlap, dxy, but it is weaker than dyz and dzx. That means, so delta bond is weaker bond than pi bond. So total we got 4 bonds between the rhenium metals. 1, 2, 3, 4. So 1 sigma bond, 2 pi bonds, and 1 delta bond. Okay, I am going to explain a molecular orbitals diagram for this. And we know here we have sigma, 2 pi, and 1 delta. This is rhenium metal, 4 orbitals, giving this one, and this is sigma bonding. This is pi bonding, delta bonding. Similarly, here we are going to get delta antibonding, pi antibonding, and sigma antibonding. So this is the molecular, and how many electrons we have? We have 4 electrons on each rhenium metal, and they will be occupied total 8 electrons. So 8 electrons will occupy the ground, starting with sigma, followed by pi, then delta. And if you see here, the energy difference between delta and delta antibonding is very less. Okay, that is the reason why here the electron used to excite to the delta level easily. So delta star transition means delta bonding and delta antibonding. Generally it takes place regularly. That's the reason why it shows, rhenium complex shows royal blue color because of its transition, royal blue color. Okay, so these are all the few, and you can see here the structure of this complex. If you see, 2 square planar units are existing in eclipsed form. Okay, third one, eclipsed. You know, eclipsed and staggered. So eclipsed means exactly the chlorines are on in the same angle. Okay, in eclipsed. Generally eclipsed conformation is very unstable, but in this case it is stable. The reason is because of the fourth bond, that is delta bond, there is a decrease in the potential energy. Okay, that decrease in the potential energy is greater than the steric hindrance. Steric hindrance. That is the reason why eclipsed conformation of rhenium complex is more stable in this case. Even though we know that eclipsed means there will be a lot of steric hindrance, and generally such type of conformations are not stable. But rhenium complex is more stable in eclipsed conformation because the decrease in potential energy due to the delta bond is greater than that of the steric hindrance. That's why it forms a stable eclipsed form. So that is about. So if you see the hybridization of rhenium, in this case it is dsp2 hybridization, and each rhenium is occupying a square planar geometry, you can see, and there exist 4 bonds between rhenium metals, 1 sigma, 2 pi and 1 delta bond. Delta bond is forming because of dxy sideways overlap, and this is molecular orbital diagram. Why I gave this diagram is to show that there is a possibility of delta antibonding transition. So electron is possible to transit between delta and delta antibonding molecular orbitals. That's the reason why it shows a royal blue color. Okay, and moreover it is stable in eclipsed conformation. I told you the reason for that. Okay, these are the few interesting factors about the rhenium complex. And as well as if you see this one, when they undergo sideways overlap, the orbitals will be completely filled to electrons. So there is no empty single electron on rhenium atom. That's why it acts as a diamagnetic molecule, diamagnetic cluster. Rhenium is a diamagnetic compound. So it shows diamagnetic character. Even though there are single electrons in the rhenium, because they are involved in the bond formation, there is no spin-free electron in this complex. That's why it acts as a diamagnetic metal cluster. So those are the few interesting factors about rhenium complex. I hope this video will be helpful for you. Thank you for watching. Please subscribe to my channel for more videos.